Okay, we're recording and we're live to the audience. Dennis, you're able to, or I guess you're not logged on. If someone can chime in real quick on the chat and confirm for me that you're able to see Dennis's presentation, the Local Safety Academy slide, that would be great. And
Are you going to do your little intro first, Anthony?
yep, we see the slides. Yeah, I'll do my quick intro before we get to that. I wanted to make sure that I'm sharing the proper screen because I've got a dual monitor setup. So as I typically like to do, well, good morning, everyone. Welcome to the Safety Academy for this month. My name is Anthony Chamont with Tyndall Oliver. Co-presenting today with Kevin Modery from Tyndall as well. Everyone received this notice via email about today's webinar. That's why you're here. If you have any questions or if you want to be able to get to the location where we store our files, there's a link right on the notice to the TampaBayTrafficSafety.com webpage. It opens up our fancy little webpage here that tells you all the current webinars that we've completed, the one that we're about to do, and the upcoming ones. If you want to share the registration link with anybody that is not currently registered, this is the link for that. It's just go to webinar registration, and this is the location as well where we have all of our prior recordings and presentations. We record these sessions for future viewing, and we provide the PDFs of the presentations. You'll notice in your handouts that you also have the PDF of today's presentation right through the GoToWebinar window, and there is also a Word document form for your professional development hours if you're a professional engineer. With that, I'll bring up Dennis's introduction, and he'll give us a quick intro on the Academy itself, where we are, what is it, why we're all here.
Okay, this is Dennis, and I'm operating off the phone today instead of my computer because I've got a little glitch in my computer today, but with Anthony's help, we should be able to get through this. I first want to welcome you to the District 7 Safety Academy and participating in the 6th District 7 Safety Academy webinar for 2016. Today's webinar topic is proactive data-driven safety project selection, and this will be presented by Anthony Chamont, who's a PE, also a District 7 consultant with Tyndall Oliver in Tampa, Florida, and Kevin Modery, PE, Tyndall Oliver, who's out of Fort Lauderdale and a Florida safety engineer, and they will be presenting the topic. And with that, I would just like to turn over to my introduction presentation, and this is the District 7 Local Agency Traffic Safety Academy. And what is it? It is the academy that's been set up to provide information regarding safety-related issues to enhance the local safety programs in your particular area. When does it begin? How do I register? This is the 4th year of the webinar series, and it started on January 6th, and they usually run from 10 to 12 o'clock on when we do have them. And the last one is scheduled for December 14th, and the reason for the asterisk on the slide is the fact that we may or may not have one in there because by November 16th we will have 12 webinars, but we may hold this one for a 13th one. Usually at a minimum of 1 hour, but no more than 2 hours. And as Anthony mentioned before, there's a place to go register, and that link is here. And also you can go to the Academy webpage for information on the Safety Academy. Then in the workshop series slide, today's presentation, as I mentioned, is proactive data-driven safety project selection. As you can see, the previous ones that we've held or had, and they're completed, and the ones for the future. And we've got a couple that are still outstanding. Also, this session is being submitted for AICP CM credits, and also topics are still remaining for these following 2 dates, 8/17 and 11/16, and I think there was one on the previous page that was missing, but it is still, and I'll share that with you out on the webpage, Safety Academy webpage. And then if you have any PVHs, this is the connection to that, to Larry Hagan, consultantservices.com, and the PVH form that Anthony already mentioned. If you ever have any questions, you can email me or you can give me a call, and I appreciate your time. Anthony? Evan?
All right, thank you, Dennis. Let's swap over, bring up our presentation. And I'll do my best to moderate the chat, which I usually do during these presentations. I like these presentations to be interactive, you know, where we're going back and forth, that I'm pulling double duty as both the presenter and the moderator today, so it's going to be a little bit more difficult. Hey, Kevin, on your end, are you able to bring up the chat while I'm showing?
Yeah, I have it on my other screen, so I can see it as well.
Perfect. So, Kevin, the co-presenter, or I guess I don't know who's the mid-lead presenter here. You're going to do most of the intro, but let me know if there's questions in the chat that come up during the presentation, and we'll pause. I absolutely like having questions in the middle of the presentation and making it interactive, and you know, if anybody is interested in the topics as we go along. But that's Dennis, you know, said, you know, my name is Anthony Schmock from Tim Oliver. I've got Kevin Montery on the line. We're doing the presentation off of my screen. I'm in Tampa. He's in Fort Lauderdale. This should be fun. We're talking about proactive, data-driven safety project selection. A big component of that, you know, not just the processes of how we do it and the types of projects that we've done, but we plan to spend a good bit of time during this presentation just talking about understanding the data itself. We feel that it's really important to know where the data comes from, how it's used, how to select it, how to query it, the different data sources. So it's not, you know, this webinar is not entirely a how-to identify project. We will get to that and we'll show some examples. But in order to even get to the how-to, we need to take a step back and talk about crash data, talk about the prioritization of those safety projects when they're selected. We'll talk some about benefit costs. We'll talk about net present value. There's a whole slew of things. From your end, Kevin, you should be able to advance the slides. I don't know if you want to try that since you're doing the first couple of. Yeah, there you go.
Sure.
So the workshop series, Dennis already talked about this, so we'll just kind of gloss over the screen. But we wanted to again let you know that there's some upcoming webinars that are coming today. You know, there's 3 more that are scheduled throughout the year. And here's your agenda, Kevin, if you want to.
Yeah, first we're just going to go over being reactive and proactive with the crash data, and then we will explain where the crash data comes from and how you can use it and different sources where you can get them from. Then we will get into more using the crash data towards improvements, road improvements, by using crash modification factors, again, then getting a benefit cost, net present value, and then finally we will go towards the end, go towards a systematic approach to identifying basically segments or corridors that may need improvements, but yet does not have that crash pattern. Like you're not being reactive. So to start, what is the difference between being reactive and proactive? The definitions are up there. Basically, being reactive is you're waiting for there to be a problem, while proactive is you are anticipating it. So instead of waiting for, you know, several angle crashes to happen at an intersection, you know, if you know that there's going to be a crash problem at this intersection, go ahead and anticipate maybe putting up a traffic signal.
If I can elaborate on that, Kevin.
Sure. Let me go back.
There's I wanted to talk a little bit more about this because it's a bit of a point of contention between the purists in the safety engineering world to say that we're being proactive when we're looking at historical crash data. We're fully aware of the fact that we're in fact being reactive because the proactive safety data-driven things are predictive models. You know, to look at the future, you know, is to be proactive. And what we are doing with crash data is looking at the history of. So we are following, you know, like FHWA's reactive looking at the historical crash costs and things of that nature. So we're fully aware of that. But you'll see with some of the examples and some of the things that we do that we feel that although we're looking at historical data, it's not just waiting for a problem, waiting for a citizen to call. If you're at if you're at DOT or one of the local agencies, for you to go out and then pull the crash data and look at it. What we try to do, the way that I call it that we're being proactive, is that we look at the historical data and we try to identify locations maybe that are beginning to have crash problems before they become a larger problem, or another way also kind of like a bottom-up and a top-down approach. If we are looking at a particular high crash location in a reactive manner because it's a location that has a history of crashes, and we identify an interesting pattern in that crash data. There's a unique geometry. There's just something different about it. We always ask ourselves the question proactively, I wonder if there are other locations in the municipality, in the county, in the city that have similar crash patterns, that have similar geometry. So then we do a proactive system-wide identification of locations that meet the criteria. It all started because somebody called and said there was a problem, but now we're looking ahead and we're going to identify all those locations that also meet the criteria and see about programming improvements along those. So it's, we know that we're looking at historical data, but we call it being proactive because, we're being ambitious about looking at the locations before they become problems and before they come to us.
And that moves into where the data comes from. You need to have accurate data before you can do any of these things. So the first thing you need to occur is an actual crash. And the crash is then filled out by one of the officers. You can be a serious guy or a goofy guy, a guy with great handwriting or awful handwriting. They're going to be the ones filling out the actual crash reports, the HSMV 910S. And then these reports, they have the crash type, the person's information, if there's any witnesses, usually a pretty good picture of what actually happened at the crash, and then a narrative. And this all goes into the Florida Highway Safety and Motor Vehicles and to other crash data management software programs. Now the crash reports, oops, let me go back. Crash reports, as I mentioned, has the crash, the roadway information, what did it occur on wet pavement or dry pavement, lighting conditions, was it a nighttime crash or a daytime crash, and you can then compare that with like the statewide average to see if there's an actual trend of crashes going on. Other things to look for is the crash type. Just because it says angle or left turn does not actually make it an angle or left turn crash. Sometimes the officer might not understand the difference, and he might think a northbound left turn striking a southbound actual an angle crash when actually it's a left turn for our purposes. So you definitely need to check that with the narrative and the picture. Other things on this, the first page is usually the witnesses and if there's any property damage. The second page is typically the vehicle information. Was it a truck, motorcycle, small vehicle, etc. Then violation. It fails to traffic.
Came on. Okay. Keep going, Kevin.
And just was the person, did he run a red light, etc. Let me move to the next slide. The next page is typically the person's information. Things to look out for is, was the person on alcohol or drugs? Was there any passengers? They check the injury type and if they're distracted. Especially now as everybody has a cell phone, you get a lot of people texting and stuff. And the officers are trying to look out for that, to note that on the report as well. Then you have the narrative. The narrative is a great place. It's probably the second place I usually look when I first open a crash report. I'll typically go to the back and look at the image first to see what's going on, and then I'll just check that with the narrative to actually understand what happened. You know, if you have a bicycle crash, was it the bicyclist's fault or was it the vehicle's fault? I read a report this morning of just a bicyclist riding in the bike lane, and you know, if you looked at the just reading the report bicycle crash, you would think that it was the vehicle's fault, but the bicyclist cut the vehicle off and made a U-turn in front of them. That's something you can easily see in a picture or read from the narrative. But if the narrative is not legible, that can be difficult. And then the last page is the diagram.
So to kind of tie that all together, I mean, the point of looking at the crash reports and doing a quick little overview is, again, understanding the data is paramount to knowing what you can even do as far as, say, proactive systemic identification. And you'll see a few examples later, but you need to know that from the HSMV, the custodians of the crash data, the Department of Highway Safety and Motor Vehicles, the data is divided into 3 tables. You have an event table, which has all the information that relates what type of crash it actually is, where it occurred, you know, and the roadway condition. It's the information about the actual crash. It is also divided into a vehicle table, so you can have multiple vehicles for every one crash, and there's the information about the vehicles and the vehicle movement, the direction, and where they occurred. And then there is also a driver table, or a person table, rather, and there can be multiple people in each vehicle. So we have the information for the crash, all the vehicles that were involved, and all the people, their individual injuries, if the driver was under the influence of alcohol or any drugs, and you know, distractions and other things. So as you're thinking in your system, in your municipality, you know, the item that you are interested in, that you would like to do a systemic study for and be proactive about, those are the fields that you can select. You can look at just hotspots and look at total crashes. You can look at by injury severity and find locations where people are getting hurt. You can look by location type and see crashes that are happening at medians. You can look by the vehicles and look at, you know, truck-related crashes. You can look by the people and look at, you know, so it's understanding the data is important to be proactive in your selection of locations.
And where does all this crash data go? It goes to the Department of Highway Safety and Motor Vehicles, of which then the crashes go towards FIRES, or the Florida Integrated Report Exchange System, and then we can get that through our various crash data management softwares. Just last year, there was over 370,000 crashes. If you were to do that manually, that would take forever. There is no way you could be proactive trying to fix these, you know, crash issues. That's why we use a CDMS. You can, you know, quickly drag an area, pull up the crashes, check out tables, see if there's injuries, fatals, you know, see pedestrian bike crashes, and also get a graph of what's going on. The different sources that are available are Cars Online, Signal 4, and our CDMS. These tools report collision diagrams. They can plot it towards the intersection. You can see them where they are X, Y. They do a lot of cool things, and it's much quicker than doing it by hand. But you still have to QC the data, as we mentioned earlier. For example, these 2 crash types, you know, they look like an angle and a side swipe, but are they really? Nope, this first one was actually a left turn. And then this one is actually like a weird left turn, I guess. Location. Just because a crash report says it's at an intersection such as US 98 and 301 doesn't really mean it's within your study area. You need to check that. There are several intersections that have the same names, especially when you get towards downtown, such as Main Streets and First Street, etc. You got to pay attention to that. Make sure they're at the right spot. Also, you need to check the geocode. You might get a lot of crashes reported where, the officer simply just filled out the crash report. If he went to Dunkin' Donuts, Subway, or, Panera or something, and he was in the parking lot filling that out, it's going to code there instead of the actual intersection, so you need to check that. And finally, you also want to check out milepost 00. I'm from District 4, and we have a lot of, we have the Everglades on the west side. And I just had a study last week where I took me a second to realize that I had basically Atlantic Avenue and Boynton Beach Boulevard starting on State Road 7, US 441. Both had milepost 00 at that location. Now what happens is if crashes are identified along corridor cannot be located, they get placed on mile 00. And so I had basically a high number of pedestrian bike crashes, angle crashes, and left turn crashes on a corridor that really didn't have much going on. So you definitely need to QC your data to make sure you take crashes.
If I can add to that conversation a little bit, Kevin.
Sure.
Not only understanding the data and the fields that are available are important, but just knowing how the crashes are located and how you can select them is important as well. The milepost 0 challenges that we come across that Kevin was alluding to relate to data that is on the state highway system. That's DOT's roadways, state roads and U.S. highways that come from the crash analysis reporting system, DOT's CAR database. Crashes from going back to, let me go back to a couple slides ago here. Going back to this, the fires is the consultant, APRIS is the consultant for the Department of Highway Safety Motor Vehicles. Fires is the portal that they built that gives people access to export their data. The data comes from them in a relational database, that vehicle, event, and location table. And the locations, for the most part from fires, there is an on-street and a cross-street. So if you have a node layer and you have a way of aggregating crashes to those nodes based on what the police officer wrote, you're able to aggregate and locate the crashes based off of intersections. The way that most of the crashes that come out of there, people locate them is by their latitude and their longitude. Every crash has an XY. And, XYs are plus or minus whatever, if there's a cloud flying overhead, the XY, the satellite didn't see the device that was coding the crash, and you can have a little bit of an error in that. Or something that we, early on, I think they're correcting this, but early on, as Kevin said also, kind of the joke of the crashes were all located at the Dunkin' Donuts down the street. I mean, that actually was happening, not so much at Dunkin' Donuts, but like at the gas station in the Southwest Quadrant, for example. A lot of the crashes at a particular intersection, when you map them by their latitude and their longitude, appear to be occurring at a parking lot or at a gas station in one of the corners. And what's happening, or what was happening, is that the reporting officer would park their car in that spot, and that's where they fill out the report. And the XYs were not being corrected and being moved over to the intersection. So, those are things to watch out for. Car Online does something really cool. They add section number and milepost to the crashes. If you do any DOT work, you're aware of their section number milepost and linear referencing system. It's fantastic. I mean, there's everything has a benefit and a negative. That section number milepost allows us to do some analysis that I'll show in a little bit that can't be done any other way. But there's a few caveats to using this data. Where two state roads intersect, that one location can be described by one of two sets of section number mileposts. If you're doing a long enough corridor, there are locations as well where a section changes at a major intersection. So you'll have not one corridor, but you'll have a selection of two different section numbers. The other thing that happens is that milepost 0. In the database, it appears that crashes that are located to the proper on-street, we know that the crash happened along US 41. But we don't know where on US 41 the crash happened, because maybe it's an address, or the police officer just didn't fill out the cross street in a legible manner, and the person that digitized that and put it into the database mistyped it. those crashes have a null value for the milepost. They have a, it's a blank. Databases kind of abhor blank null values. Queries just don't work very well, and what the system does is zero them out. Unfortunately, milepost 0 is an actual location. That's the beginning of the milepost. So if you're doing work for DOT and you're doing systemic studies and you're doing corridor-wide things, or you're doing a selection where you include milepost 0, you need to know that you may be grabbing crashes that are anywhere along the segment that weren't able to be located automatically by the system. Signal 4 is put together by UF, the McTran Center, those guys over there. They have a direct link to the HSMB data. They get very up-to-date data. I mean, this system is great. They have a bunch of grad students that are working on this. Recently, they added some analytical tools to that allows you to look at top locations, and they're beginning to aggregate things. For the longest time, what they were doing basically was just mapping the data and allowing someone to query it at a specific location. By their XYs, basically. So this was working off of XYs. And then the CDMS, the Crash Data Management System that we developed in-house, does kind of a combination of things, but really the clients that use the CDMS, the value that they gain is Kevin and I to do the studies for them. It's if we're doing engineering studies for an agency, they have access to the CDMS and they're able to query things themselves, and there's some proprietary things that we developed in there, but what we use is the data from fires and the data from CAR to do that. And back to you.
We did get a question. It's where would you go to look for statewide averages for crashes?
The statewide averages, well, it depends. There are some fields that are readily available online. If you Google the what is that called? Not the synopsis report, but there's an annual report that HSMB puts together. I think it directs you to the fires database, and there's an annual report that has a handful of attributes. You can see by county, by city. You can see number of bikes, number of heads. There's a few things like that. But if you need something a little more specific, I can exit out of this and show you a report that we're able to access from the Department of Transportation off of their mainframe. They get one of my teams. Yes, you're going to see under the hood of our engineering team site for Tyndall Oliver. Oh, this is me. This is Kevin. The people that are presenting. That's our safety team. Crash stats. There's a few things. One of these is the crash location summary report from it's a mainframe like green bar report. This has on-system crashes only, I believe. But your district, your DTOE, your district safety engineer can pull this for you for whatever section you need. But you see by first harmful events statewide, how many crashes, like 10,000 crashes involve overturning a rollover. That's 1% of all crashes. 400,000 locations or events occurred. Motor vehicle in transit. That's 80% of the crashes. So you've got first harmful event. You have by day. You have by manner of collision. You have by first harmful event location. You have by whether or not school buses are related. Lighting condition. This is useful. That 69% of the crashes occurred at night. That basically means that 30%, I guess if you round up, 30% occurred at night. But note that 49% of them were not coded, and 4.5% were dusk and dawn, and some of them are dark lighted. So when you're doing something like a systemic evaluation, being proactive to identify locations that are dark that you want to do lighting improvements for, are you going to look at night as defined by not equal to daylight, or are you going to define night as dark, not lighted, or are you going to define it including dusk and dawn, which we tend to do because those are kind of times of inclement lighting where lighting may help. You have by weather condition, you have by contributing cause, environmental, relation to junction, whether or not it's in a work zone, law enforcement, There's vehicle body type, traffic control, roadway alignment, roadway grade, vehicle defects, direction of travel. This goes on for another couple pages here, but I mean, if this is the type of information that you need, your district safety engineer can provide a report for you for this, and this can be pulled for a county, for a district, or statewide for any given date range. And I want to say it only includes on system. I don't know if this includes all crashes. This is county. I'm trying to see if this tells me max brakes only. Yeah, I'm not sure. I'm going to have to follow up to see if this includes location summary for state roads. This is only available. These statewide numbers from the DOT are available for the state highway system. If you wanted to pull statewide crash stats that were not in here, I mean, you have to get access to one of the databases that has statewide, and just kind of you can pull the number yourself. You could do that from Signal 4 if you have access to that. I don't know. Hopefully that answers your question. Oops.
Okay, great. Now, these tools that are available, they can do quite a bit of things. You can export it to Excel, to where you can, if you wanted to make custom graphs or anything, you can do it that way. There's also has standard summary reports. It usually have like what we were mentioning, the lighting, the road conditions, crash types, location, just quite a bit. Personally, I like to get these reports at the very beginning prior to doing a field review, just to get a feel of what's going on out there. Other things that these can do is plotting collision diagrams at the intersection or along the segment. You can also make graphs of when they're occurring, like was it dusk, dawn, during the day, nighttime, etc. And here's some of the figures we've actually made with these. Now, a reactive use of crash data is simply just waiting for these crashes to occur and then fixing them. Now, what we want to do more often is obviously be more proactive, such as doing the studies, safety studies, 3R projects, project prioritization, and coming up with improvements to fix them. And with a lot of these...
with those 3R projects and the funding justification and things, I think a neat thing that you can do with the crash data as well, that's it's kind of proactive, is to piggyback safety projects on existing capital improvement projects that are planned. Knowing that money is going to be spent anyway on a resurfacing project, it's great to take those locations and just do a safety study at them and see if there are things that can be mitigated. And perhaps a simple 3R project can be enhanced with federal safety funds to, maybe close some medians or do some modifications along the roadway, add a bike lane, do a buffer bike lane, or whatever the case may be, to enhance the roadway and not just kind of build it back how it was. You can do a proactive evaluation, which is, that's something that we do pretty regularly, is look at the upcoming 3R projects and DOT's work program and provide crash data so that they can look at it and see if there's any improvements that can be done. So it's integrating safety into kind of the planning process of the upcoming projects. That's a great way to be proactive with safety improvements.
With a lot of these studies, you're going to need to use benefit cost calculations. So we just wanted to do a quick overview of it all, just so that we all have a good understanding of it. Benefit cost is basically the annual benefit over the annual cost. And to calculate the benefit, let me look at it again. You're going to need the crashes, a reduction factor, and then the cost per crash. And and you just multiply the 3 together. And then to get the reduction, you're going to go to clearinghouse and get a crash modification factor. And you can get the crash reduction factor simply by 1 minus that. And the sources for these CMFs are the Highway Safety Manual, the clearinghouse, and the desktop reference. Typically, we don't use the desktop reference too much anymore. It's 2008, so it's older data. So you want to stick more with the Highway Safety Manual or the clearinghouse. Now, for the CMFs, anything less than 1 reduces crashes, and anything equal to or greater than 1 increases crashes. What you want to look for is a quality rating of at least 3. You can use less than 3 if you're not finding anything, but just talk with your FDOT project manager, or make sure it's okay first. But the higher the quality rating, the more studies that have been done out there proving that this improvement actually does work. And which countermeasure would you choose from? You're going to want to pay attention to the crash type, the crash severity, and the area type. You don't want to be putting an improvement that's meant for a rural road if you have urban setting. It's just, you got to pay attention to that. It has different effects. It might increase crashes, for example, in your area if you're using a rural. And each one of those has several other conditions you're going to want to look at. For example, installing a traffic signal. This one, the prior condition was stop controlled. A difference could be, you might have a roundabout there right now. Other things to check is applicability. This is what I was mentioning earlier with the area type being rural, AADT, the intersection geometry. You just want to make sure you're using the correct CMF or something that's at least close to it. And with all these CMFs, there's quite a bit of them. For example, just pulling a traffic signal has over 30. You're not going to use every single one, otherwise your benefit cost is going to get quite, lengthy. But an easy thing to do at the bottom of the page is you can export these to Excel. And if you open them in Excel, you can filter them, remove all the rules. Maybe if you have quite a bit, remove the 2 stars, and just try to get it as close to your corridor as possible. They can be combined if you're just using a couple CMFs and you don't have a lot to deal with. This equation explains how to do it. It's pretty straightforward. Just don't add them or anything. Try to make sure to just follow it the correct way. An easier way of doing it is simply having a spreadsheet with it. Just keep track of the different CMFs that apply to the different things. For example, if you have an angle crash for a CMF of 0.23, which would be a CRF of 77%, apply to only those. Don't be applying then to the left turn or rear ends or all crashes. And if you did have a separate CMF, split it up. Try not to double count anything. And then at the end, you would just multiply the crashes for each of the years by the CRF to get how many crashes are reduced, and then you simply add them up together to get your total benefit, or your total reduction, I'm sorry.
And that sounds simple, what Kevin just sort of went over quickly on benefit costs. There's a whole other Safety Academy webinar that I did, I think 3 years ago, like a whole hour and a half on how to do benefit costs. So feel free to go into that historical stuff and see the one that I did on this. But it's this is hard. I mean, it sounds really simple. Just, hey, put in your countermeasure and go in there, select the number, punch it into the spreadsheet, and you're good to go. But I mean, there's an art to it. The clearinghouse and the Highway Safety Manual there are a lot, and they're kind of specific. And what you'll find often is that the improvement that you're looking for isn't even listed, or there's something similar but it doesn't quite fit, or you'll have conflicting information. A great example of that, Kevin and I were actually talking about it before we started, let me exit the presentation again and go and do a little show and tell. In the crash modification factor clearinghouse, you can type in here, whatever it is that you're looking for. So bike lane, for example, is a really interesting one because, and they both make sense. If you go provide bike lanes, okay, that sounds pretty good. 2 stars, it's the only one that's in here. I know that we want to use ones that are kind of 3 or more. We have crash modification of 65, which means that we're going to reduce 35% of the crashes. This is the number that goes into your spreadsheet. If you have if your district or whoever you're working with has one that they provide for you, that's the number that goes in. So this makes sense. We like that. If we provide a bike lane, we reduce 35% of fatal, serious injury, and minor injury vehicle and bicycle crashes. So if you're doing a corridor-wide study, you would select all of your fatal and serious injury crashes. It doesn't matter the area type. This seems to apply for urban, rural, and suburban. And you do a 35% reduction. It's nice and easy, right? Straightforward. But you saw that there's 39 countermeasures, not just provide bike lanes, but there's all these other countermeasures in here. And if you look at install bike lanes, for example, now you're seeing in the urban area, all crash types, a negative reduction of crashes. So it increases bicycle crashes by 5%, increases fatal and serious injury and minor injury crashes in the urban area by 15%, but then it also reduces 32% of all crashes in the urban area. How can this be? The answer to how can this be is that this came from a 2008 report, and you can click on here and look at the actual, you can read the, kind of the background information and do some research on this to see the conditions of why this occurred. This was a 2014 study done by somebody else, so there's different studies in here and there's different reductions. So it's not as clear cut as type your improvement, grab your countermeasure and go. Work with your project manager if you're doing studies for them prior to kind of going to town and doing some benefit cost calculations, because they, based on their knowledge and their history and their preference for the area, I know that some of our clients don't like it when we use the all. Like they would be okay with us using the bicycle one, but you wouldn't reduce 27% of all crashes simply by installing bike lanes. That doesn't make sense. You would only fix bicycle crashes. So there's caveats to this. It's challenging, and through experience working on them, there's some engineering judgment, and you kind of figure out which ones are good, which ones are not. Something that we've done in the past also is, if there's a particular improvement that isn't in especially if there's one that's not listed in here, work with your district safety engineer, with your county engineer, and hey, propose something to them. I didn't find one for this improvement, but there's this other one that's similar, but I think it's going to have a little bit less. That one says 20%. I want to, for this study, do 15%. What do you think? And kind of work with them. And yeah, that looks good. Okay, then you can move on and just kind of get the go ahead. I don't know if anybody has any questions in the chat on this, but I mean this is kind of critical to funding and justifying all of the locations that you will identify proactively. Later on, tying it back to the title of the webinars, the proactive countermeasures, proactive project selection. In the end, when you identify your projects, you're going to be looking for funds. You need to be able to fund those projects, and doing that through here is kind of the way that we do it. So it's tricky. There's a lot involved in there, and there's some countermeasures that make sense and some that don't. That's why we have the multiple sources, and there's people out there that have been doing this for a while that can help with it. So make sure to ask for help if you're working on some of these and you're not sure.
Yeah, definitely check too.
Go ahead.
Definitely check your CMS and what you get, because I can do it, and then Anthony can do the same problem, and we get totally different answers.
Yeah, hopefully similar, not totally different, but yeah.
Yeah, that's true. Hopefully similar.
The other thing also, I mean, in this is a screen cap of District 7's benefit cost / net present value calculation sheet. The state has one, FHWA has one. There's different people have different sheets in slightly different formats. And for the district, we kind of split it up so that we have fatal and injury crashes in the top, we have minor injury crashes, following the language that you saw in the clearinghouse, and then other crashes down here, regardless of the injury. You absolutely want to make sure that, for example, if whatever improvement we were doing here fixed 77% of angle crashes, and then there was another countermeasure that was being applied in the same intersection that also fixed 10% of fatal crashes, and you had some fatal crashes up here and you were doing a 10% reduction, you do not want to put fatal angle crashes up here. You want to put the fatal crashes that are not being counted somewhere else at a higher CMF. That's what Kevin was saying about double counting crashes. You want to make sure that the sum of all your crashes that are listed here are not greater than the number of crashes that you even have in your history. That's a pitfall that it's easy to fall into when you start doing an improvement that's a little bit more complicated, which they all tend to be. I mean, we never go out and do just one thing. We add a turn lane, we add a shoulder, we add some signs, we add lighting, and it's challenging getting all that in there and figuring out which one is going to be the one that gets fixed. Cost per crash.
Now, to get the actual benefit of the crashes times the reductions times the cost per crash, you're going to need what the cost per crash is. To get that, you're going to go to CARS. This is basically the same source that Anthony was showing you earlier, but a different spreadsheet. And it has the different segments broken out by lanes and the area type. For your project, you're going to want to select the one that corresponds most closely to yours, and then grab the crash cost, which is in this column here. The top one is the crash per cost, and the second one, I believe, is the cost per injury. You're going to usually 9 out of 10 times use the top number. That goes into the spreadsheet that to calculate the benefit cost. That's in the next line. This is where we got our total reduction, and now we're going to plug it into up here for this particular, study has the cost per crash of $102,000, and the total benefit is just simply the $102,000 times the total reduction of 5.82, giving you $597,000. Now, to calculate annual benefit, you can't just simply divide that by 3, and we will get into that next.
Real quick about the crash costs in the DOT output. This comes from the crash analysis reporting system also, and this actually includes, I believe this includes segment-based. I'm not sure if this includes on and off system. I think it includes only on system, as most of their things do, but it does work for the different counties. And this is really a county engineer, district engineer preference, because you are able to drill down as tightly as the roadway type. Its crash rate category is what they're called. Whether you have a 2 to 3 lane urban divided highway with raised medians, that's what the number is here, the 82,000 on that roadway type in all districts, all counties, 3-year history. The crash cost is 82,000. That's an average annualized cost statewide for that type of roadway. These reports are also able to be generated for an individual district or an individual county along the entire state. So it's up to whoever's reviewing the information for you whether or not you're using a statewide number, whether you're using a district-wide number, or whether you're using a county-wide number, and furthermore whether or not you're using the statewide average for all crashes, or whether you're using the crash cost for that particular roadway. Generally speaking, since this is a proactive countermeasures, looking at systemic projects, for the purposes of this webinar, I'll say that the number that we use when we're doing systemic studies is the statewide crash costs for all crash types, regardless of roadway type. That's a good starting base for looking at everything. Kind of like the errors are propagated evenly through the system because you're looking at a statewide average, all roads, all locations, all crashes. That number is around 150,000, 160,000, I forget the exact number, for a 3-year crash history. But if you're looking at pedestrian and bicycle crashes, which have a smaller sample size, we tend to look at a 5-year history. We're able to pull this report to see a 5-year crash history as well. So, you know, it's a matter of knowing what this is. I mean, if you see this is page number 277, this is like a 1,000-page report that has tables with numbers in it, and you know we need to know what number it is that we're looking at. So just know that you're able to pull different numbers, and they vary. And obviously, the higher the crash cost that you're using, the higher your benefit is, which means you're going to have a more favorable benefit cost. And if you're using a lower number, then you know your benefit will be lower, and you'll have a lower benefit cost. So, you know, engineering judgment again, you know, which numbers it is that we're using.
Then you're going to need to calculate the cost of the project. You guys try to be as accurate as possible. Typically, you want to use somebody that has a lot of experience in that, especially with like civil engineering and stuff. Unless it's something rather simple. If it's something striping a bike lane, for example, that's going to be a lot easier to come up with the cost than doing a whole new roadway. You'll want to convert both the total benefit and the total cost into annual payments. This is just like college all over again. Luckily, the spreadsheet that we have does that for you. I mean, you can do it by hand if you want to, but why if you have the tools? And to calculate benefit cost is simply dividing the total annual benefit, not the total benefit, but the total annual benefit by the total annual cost. And again, this is, I kind of went quickly on it, but this is breaking out the costs. You can have it for the right-of-way, engineering, structures, roadway pavement, etc., and then the different life cycles for each of those to get the cost per year. And for this example, the $199,000 annual benefit divided by the $55,000 annual cost gives you a benefit cost of 3.58.
Something to point out in that section of the spreadsheet as well is note your acronyms. CRF right there is not crash reduction factor, that's capital recovery factor. It's unfortunate that we have two acronyms in the same spreadsheet that mean very different things. So, that's not where you put in that 77% reduction. That's your capital recovery factor, moving time and money, statistic stuff.
And that's also built into your spreadsheet, correct?
Yeah, that's just built in. In this particular spreadsheet, the numbers that you type in are the ones in the yellow field, and the gray ones are calculated for you.
Finally, you're going to want to do the net present value. This kind of coincides with the benefit cost. It basically and then you want to elaborate on it? I don't mean.
The net present value, there's, again, in that BC webinar that I did, there's a whole section on net present value, so you can check that out. But the benefit cost is a ratio of the improvement over the benefit over the cost improvement. So you get a ratio of the two. The net present value takes the improvements over the life of the cycle of the project, and you take the cost and you subtract those improvements from it. So you get a magnitude of the improvement rather than a ratio. I like using benefit cost as a filtering criteria, and I like using net present value as a sorting criteria. So depending on how much money you have to spend on your safety projects, you can filter out the ones that have the highest benefit cost and then sort by the net present value and apply the appropriate funds, because that's how much money it's going to take to construct the projects. The way that you can see this, you can play around with the numbers. If you have Project A and Project B, and both of them have the same benefit cost ratio, one project could have twice as many crashes, and at that location it is a larger intersection, so the improvement is going to be twice as expensive. But you're doing the same improvement at two different locations, so the crash modification is the same. For those two intersections, the benefit to cost ratio is going to be the same because you multiply the number of crashes, you multiply by 2 the number of your improvement, and you'll end up with the same benefit cost. However, the one that has twice as many crashes, where it's a larger improvement cost, is going to have a higher net present value because you're fixing more crashes more quickly. It's kind of like a rate at which you're fixing the crashes. So it's just FHWA and DOT are using net present value for their prioritization. So we added it to the spreadsheet and always calculate both.
And again, this spreadsheet does pretty much all of that. You're just going to want to input your crashes. Make sure you separate them, as Anthony and I were leveraging earlier, and put in your CRFs and noting that this CRF is not the same as this CRF. And putting it together, you're going to grab the cost per crash from the CARS sheet and just making sure that whichever value you use is okay with your particular district. And that basically sums up the BC and net present value.
Systemic studies. I'm going to talk about some fun things that we've done. This spreadsheet here is we're looking at something called the crash type matrix. It's some throughout the years of us doing safety studies for different clients, we've done identifications system-wide of, for example, show me locations where we can do some protected left turns, because they want to fix signalized intersections and convert some things to maybe flashing yellow arrows, or they want to take some protected permissive phasing and change them to protected only. I'm looking at, for example, this column here, the protected left turn phase. What we did to come up with that column is to take all of the crashes in the system and tag them as to whether or not they involve left turn crashes at signalized intersections. If they did, as a Boolean, we would put a yes, and if they didn't, we would put a no. And the crashes are aggregated in the system that was used to develop this by an intersection node. So we have an intersection number over here. I realize that these numbers are small on the screen, but we have an intersection, and then going across, we know that 21, I believe this is a percent, 21% of the crashes at this location involve a protected left turn. So if you did that for every single intersection in your municipality, and then you sorted by the percent of protected left turn location, then what you would end up with is a top candidate list. These are your top 10 locations that you need to look at, proactively, and go out there and do an evaluation, read their crash reports, and figure out what's going on. In the example that the spreadsheet is showing, we sorted by lane departure. At the time that we put this together, that was kind of one of the hot topic items. We had the high-risk rural roads and the lane departure crashes. It's one of the state strategic highway safety plan emphasis areas. So when you sort a proactive sort of systemic spreadsheet like this by lane departure, you end up with your top locations by lane departure, your next 10 and your next 10 going down the list. Interestingly, if you combine all of the kind of countermeasures or searching criteria, then you can see at this intersection over here, for example, you also have vulnerable road users. That's in the top 10. You scroll across, and closed median is also an issue. You scroll across, access management review, which is kind of related to closed median, is also an issue. Bicycle and pedestrian is also an issue, which is again related to vulnerable road users. So at a glance, if you're interested in lane departure crashes, this is a really good corridor to look at. We haven't gotten a citizen call about the location. We haven't gotten, we're just going to be proactive, and we're going to say, hey, let's evaluate this location and see if something can be done. Schedule one of your consultants to go do a road safety audit out there and get some improvements, and it's going to be a good location because you have a good number of severe injury crashes, and it's this is a really useful tool when you're looking at proactive project selection to identify locations. A different way of looking at the information, again, now that we know about crash data, we know how benefit cost works, we know where it comes from, we know how it's located. The prior example, the matrix, is using the node aggregation of the crashes, not the XYs, not the linear referencing, but the fact that crashes can be aggregated to an intersection and you can do statistics on them. This is an example of something that you can do along the state highway system with their linear referencing system. Those are crashes that they're given a section number and a milepost. If you're familiar with DOT work, you know what I'm talking about here. The routed rolling segment crashes. What we did for this evaluation is we grouped crashes, we grouped the segments into 1/2 mile rolling little segments, and we selected all the crashes at each of the segments, along this roadway from milepost 0 to milepost half, from milepost half to milepost 1, from milepost 1 to milepost 1.5, from milepost 1.5 to milepost 2, all along the corridor. Selected all the crashes. And then we went back and selected all the crashes that occurred at night along each of those corridors. We took those two and divided them to get a nighttime percentage. We saw earlier that the nighttime percent statewide is somewhere around 30 from the question that we answered earlier. So for this selection, we decided to do our symbology for 25, just to kind of get some that were close to it. So this map shows a rolling percentage, 5-year history along Pasco County's state highway system crashes that are more than 25%. And the number in here is also the number of nighttime pedestrian crashes. And I'm sorry, the number is the number of segment crashes, and there's dots that are kind of hard to see. You can see them over here for pedestrian and bicycle. So if we're interested in doing nighttime improvements along the state highway system, it's pretty easy to see. I mean, these are locations that are pretty close. They're around that 25%. These locations are higher, so this roadway definitely is a good candidate. This segment of roadway is a good candidate. It's got a good number of crashes. Nighttime bicycle and pedestrian crashes are showing up over here, where we have greater than 25% nighttime crashes, so we're close to the statewide average. We're maybe a little above. And over here in this area, we have some red as well. So it's a way where, using the way that the crashes are located and mapped, using GIS and some fancy tools, we're able to generate these types of maps and identify candidate locations. Each of those locations would then be reviewed in detail. Pull all the crashes and look at it, go out and do some field reviews, see what's happening. Maybe it's a maintenance item. Maybe it's a light segment that's out that just needs to be corrected. Maybe there's trees that are covering the roadway. I mean, whatever the case may be, for this particular location, you can identify new projects. Another thing to do with this, I alluded to earlier, the capital improvement projects, the work program projects. You definitely want to see if there's work program projects along some of those segments that have been selected, and depending on the type of project, if it's appropriate, you can try to piggyback onto those projects and see if you can do improvements along them, or if it's too late, the project is coming along, or it's a particular project that can't be edited, and to leave that particular corridor alone for now, because there is an upcoming project that's maybe going to fix the problem already. So evaluate it afterwards, and then be proactive once that project is completed. Recheck it to see if the problem has been fixed. Intersection summary maps, again, similar to the matrix that we looked at. What we're looking at here in this map is Hillsborough County. We're looking at bicycle and pedestrian crashes, and we're looking at 1 year. This is a 1-year history. And if you have a system that aggregates your crashes to a node, you're able to answer the question, what is your intersection with the most crashes that meet X criteria? Whatever it is that is the hot button topic, whatever the political thing is at the moment, whatever there's funding for, if there's a particular set aside earmarked pot of money to identify types of projects, because I mean that's what this is all about in the end, is finding locations. So you're able to take a particular subset of the overall data, select them out, aggregate the intersection, and build a thematic map like this that has big red dots where there's more crashes, smaller orange dots where there's a little bit less, smaller yellow, all the way down to small green dots, and you're able to see what your problem areas are. So you can either, for example, if we look at the zoom, I mean, this particular corridor here is, that's a problem. Whatever road this is, I want to say is that Fletcher? I can't tell what that is. Whatever road this is right here is having problems. So even though we're looking at a intersection individual spot review, we can identify at times corridors by grouping spots that are all together. So there's advantages and disadvantages. If I go back to this intersection in the center, for example, may be really bad. There may be a problem here. But because the crashes are divided between the east-west and the north-south road, this spot here might not show up. So there's advantages and disadvantages to doing things along a segment. There's advantages and disadvantages to doing things along spots like this as well. The combination of both those items is a thematic map that we've kind of dubbed the bubble map. What we do here for this type of this works great for bicycle and pedestrian crashes, which is what we're looking at here. Bicycle and ped. This is a 3-year, 7, 8, 9, 10, 11. This is a 5-year history of crashes in the entire district, and we zoomed into a section of Pinellas County just because it was pretty and there were some red areas in there. But what the bubble map does is, rather than aggregating the crashes by whatever the police officer wrote or by looking at the section number of mileposts of those crashes, we map the crashes by their XY, just by where they're located. And then each of the crashes is buffered. There's a bubble that is created around each of the crashes. And there's a science to knowing how large to make that bubble. In GIS, let's say, for example, we want to find crashes that are grouped together. Bike and ped, we tend to do a little bit larger bubble because they're less frequent. If you were doing crashes that were more frequent, then you want to do a smaller bubble. But say you use 500 feet. You want a 500-foot or 1,000-foot buffer around each of your pedestrian crashes. And any time that the bubbles overlap, then what we do in GIS is to merge those two bubbles, and rather than having a circle, we kind of have this like nebulous blobby area. And then we do an identity of the crashes underneath those bubbles, and we count. So we count the number of spots that were initially mapped inside of our blobs, and that's the number that we end up with. So here it's difficult to see, but this could be a location that has, there could be 100 crashes inside of here, and if all you were doing was a thematic map, or you were just looking at the dots and they're all on top of each other, they're difficult to tell. What this allows us to identify is clusters and areas. For example, here is a segment it's not one roadway. It's sort of like an area. It goes along and it goes up this road and down this road and it goes past it. You're able to see in here that it's sort of like a whole cluster. This is a downtown area that has some bicycle and pedestrian challenges that, the downtowns tend to. You can see like downtown Tampa, that's the same thing. There's some corridors and there's some clusters. So this allows you to cluster your crashes and find high crash areas, not necessarily segments, spots, or corridors, or high crash areas, which is kind of neat if you want to target a particular city. And okay, we're out of those areas now. We're going to find the individual spots and work with the community traffic safety team and go out there and figure out what's going on, interview, the fire stations and the police stations, and see what's happening in the area. Now we're being proactive and we're chasing the data, even though we're chasing historical data. We're being proactive about what to do with the locations because we're finding these kind of little gems in our data. One example of this is spotlighting improvements. Here we are looking at that same routed segment analysis that I showed earlier with with nighttime crash. I think that was nighttime crashes. We're looking at a zoom in of the nighttime crash percentages for Hillsborough County. And what we did in Hillsborough County is identify the corridors and the intersections that had nighttime crashes using these thematic maps. We got a long list of locations. From the Center for Urban Transportation Research Center, Cutter, over at USF, they have a system that drives down the roadway and gets lighting data along corridors. It's fantastic. They take measurements every 10 feet, 2 measurements per lane down each lane of the roadway. You can see all the dots here. I mean, this is zoomed in pretty tight, and there's lots and lots of data. So we're able to make these heat maps. What we did was, using that lighted, routed segment analysis, we told them what corridors to go study. So then they studied all the segments, and then they gave us back the data. And then looking at signalized intersections, what this is looking at is a condition diagram of a particular intersection. You can see that there's a street light here. You can see there's a street light here. In the heat map, you can see where that street light is lighting up the data. You can see where that's lighting up the road over here. This spill out over here, even though there's no lights along there, are the lights from this gas station that are here. So you can see how that kind of influences the roadway. And what we've done is look at the lighting data at each of the quadrants, identified the nighttime crash percentages. This is above the statewide average, and pedestrian and bicycle crashes are much higher along the segment. And we can see in the condition diagram that there is a utility pole in the northeast quadrant of the intersection. So that provides an opportunity to enhance intersection lighting by adding a luminaire at that location. And this is like a pretty, I mean, work with your utility company. You know, it's just you pay for the light, and you know, if you have a maintenance agreement, and you can fix nighttime pedestrian crashes at an intersection. And it all starts with, how's the data located? Well, we have section number of mileposts. We're able to do thematic maps. We're able to zoom in. We're able to get the locations. We got some lighting data. We correlated that. We put it together, and we ended up with this really neat deliverable where we were able to fix, you know, a couple dozen intersections where we just added a single luminaire at them, and now the intersection, you know, if they were to rerun this again, we wouldn't have this dark spot in this quadrant of the intersection because there would be a light there. I mean, this is a fantastic use of the crash data for things like that. Another one that we did, which we've been doing this recently, the Bi-County Strategic Highway Safety Plan. I'll go into a little bit of the background of how this came up. Due to some of the challenges that Kevin talked about earlier in selecting countermeasures from the Crash Modification Factor Clearinghouse, what happens sometimes when you're doing a top-down, what we call a top-down safety location identification, is looking at how many crashes. So if you're finding top spots, top locations, your worst severe injury crash locations, your worst locations with the most pedestrian crashes, with the most nighttime crashes, and then not knowing what the answer is, but you know that there's a problem there. You go out and you evaluate it and you determine what the solution to that problem location is. You develop an improvement, you develop a project, and then it's time to justify the project. And it turns out that, you know, that the improvements that you came up with are not even in the countermeasure clearinghouse. So it's difficult to do these improvements. Knowing that, we work backwards from the countermeasures. The Crash Modification Factor Clearinghouse allows you to export out to Excel. You can filter out and export one countermeasure, or in the main screen, if you just hit search, it kind of brings up all of them. I did this yesterday, and there's 5,378 countermeasures in the clearinghouse. If you export all those out, you end up with an Excel spreadsheet of them. And for the Highway Safety Improvement Program in District 7, as part of their Safety Summit, we developed a by-county off-system strategic highway safety plan. But what I'm going to show you here is some of the screen caps of the on-system. The purpose of strategic highway safety plan is to reduce fatal and severe injury crashes. So we took all 5,000 countermeasures from the clearinghouse, and we sorted them by their injury severity to get only ones that are fatal and severe injury, because that's the point of HSIP. Then we took and saw the crash types, and I eliminated the ones that are all, just so that I can get, you know, run off road, vehicle, bicycle, things that are, if you understand your crash data, which you should have a good understanding of it because we talked about all that earlier, Now you know that you're able to query from the data crashes that qualify as run-off-road. You know that in the data you're able to identify bicycle pedestrian crashes, other things that would have been listed here, side swipes, rear ends, angles, those types of crashes along a segment. So now we know that these are the countermeasures that are queryable in the data, that are listed in the clearinghouse, that have proper crash modification factors that fix fatal and severe injury crashes. So we grouped all of these and counted them just so that we know how many were there for each of the crash types. We queried them. This is a screen cap of the District 7 Crash Data Management System, the tool that Tim Oliver put together. We queried them by their crash type, the front to rear, using the filters that are available in the tools. And we developed this, I call it the rainbow spreadsheet. The guys in the office make fun of me because that couldn't come up with another way of making my colors, stand out with what I needed to. And it's similar to the matrix that I showed earlier, but instead of locations, what we're looking at are countermeasures. These are the crash types that are found in the clearinghouse. We know how many countermeasures there are that fit each of those criteria, and we know the improvements that they can fix. By county, Hillsborough, Pinellas, Pasco, Hernando, and Citrus, and district-wide, I know how many daytime crashes there are. I know how many angle crashes they are. I know that 32% of the severe and injury crashes in Hillsborough County are angle crashes. I know that of all angle crashes, 42% of them occur in Hillsborough County. I know that of all crashes, 13% account for this. So I'm able to then identify the crash types that are overrepresented in each of the counties. You basically look for the reds and the oranges. For Hillsborough County, it was speeding, it was truck-related, it was angle crashes. In Pinellas County, we had bike ped, we had right-turning crashes. In Hernando County, we had, whatever these are going across. It gets harder to go across my spreadsheet. We had run-off-road, we had hit tree, so we identified the crash types. Being very specific, wanting to solve overrepresentations of crashes. If this isn't proactive use of historical data, I don't know what is. And knowing that crash type then, going back to those thematic maps that we talked about earlier that you can do for any crash type, well, now I know the crash type that I want to fix. In Pinellas County, one of them was pedestrian crashes. So here is a heat map that shows you kind of concentrations of crashes as well as, large dots where they're occurring. So, this is your short list. You go to each of those big dots and you kind of zoom in and you maybe see if there's any corridors that you can do. And you have a list of locations. Go out and do a road safety audit and figure out what's going on, or do an engineering study, do a field review, figure out what's happening, look at your transit usage. So it's a way of identifying and being proactive and finding locations to do safety projects. In Pasco County, here is the no lighting. I'm kind of really harping on no lighting. We saw the map earlier, and these are, I don't know if you remember the corridors that showed up in the other map. This was one of them. This was one of the ones that was orange. This section over here was as well. So using a different methodology, you come up with very similar answers. And if you were looking at intersections, the big blue dots are your large intersections. And if you want to do corridors, you sort of look at the orange and figure out the ones that are in between. In Hernando County, run-off-road, this is on-system only again, when we're not looking at off-system crashes, but this one intersection here had a lot, so it gave us a large kind of influence area around here. If you wanted to do corridors, this is a pretty good roadway to do something on. Maybe US 19. There's things happening with run-off-road crashes there. So recap, Kevin. I don't know if you want to chime in here before I start coughing. I'm going to drink some water.
Yeah. So basically, you want to get your crash data, QC it, make sure it's it's okay, and use the different sources such as the Signal 4, RCDMS, fires, cars, etc. And then grab your crash modification factors. You can either do all of them, like Anthony just showed, or you can go even more just specific and find ones that are related to your project. Make sure you have accurate CMFs that apply to your project, and then simply, well, maybe not simply, but calculate your benefit cost and net present value. And I think the easiest way to do that is using the spreadsheet provided by your district. And then hopefully you can also even maybe do like some of the projects that Anthony mentioned as well. And that's pretty much it. There are a couple questions. Which software is producing the crash diagrams? That's actually from the one you saw earlier. Let me see if I can pull up that slide. It is from our CDMS at Tyndale.
Whoops. Yeah, sorry. Like we're both trying to control the same computer at the same time.
Oh, I'll let you go.
Yeah, this. Who asked the question? Yeah, Christine. Yeah, this is a we developed an in-house tool that looks at collision diagrams. We developed this for there's a bunch of cities and counties and a couple of DOT districts that are using it. But I don't know if you used Intersection Magic back in the day, but that was kind of a mess. What you're looking at here is at intersection crashes are the ones that are inside of this area. And then the crashes that are on the approaches, you know, the northbound approach, the westbound approach, the eastbound, and the southbound are over here. All pedestrian and bicycle crashes would be kind of tagged to the center of the intersection because if you know the crash data, it's really difficult to know exactly where the crashes are occurring. So we just kind of tag them all in the center. And there's a handful of crashes down here. You can see there's 40 that are not diagrammed out of the 218 at this intersection. These are crashes that the computer system was just not able to do for us. It's something where there is conflicting data. For example, there would be a northbound versus northbound collision where the crash type is angled, or a northbound left turn. Like that's not possible. In order to be an angle or a left turn, they need to be coming in opposite directions or from an opposite roadway. So those crashes, rather than assuming and being wrong, the system puts them into the question mark, and then a person needs to go in there and clean this up. But this is we take every crash that comes to us from car and from fires, and we identify based off of a series of it's vehicle movement, vehicle direction, harmful event, site location, whether or not what type of crash they are. Whether it's a left turn crash, whether it's an angle crash, whether they involve U-turns, whether it's rear end at the intersection, right turn coming from our driveway, and kind of put it all together. We can also leverage this information, like in the previous slide. A couple slides back. One slide forward. Where is it? Right here. Those same symbols we've been able to take on state highway system crashes. We can do it off system by XYs as well, but it's a little bit trickier to be able to take those and do them along a corridor, so that rather than doing intersection by intersection, you're seeing the crashes, like these crashes happen here, this crash happened here, this crash happened here, this crash is missing a picture, this crash happened at that location. So we're able to do spot and segment collision diagram corridors, which is a really interesting tool. Happy birthday to me. Yay. What is the difference between the two rows in that column? I wish I knew how far back this was. The two rows in that column. I'm thinking
it's the benefit cost table, the spreadsheet?
Yeah, I'm thinking you were talking about this, the CMF versus the CRF. They're just the inverses of each other. It's 1 minus the CRF gives you the CMF. You see like 23 and 77. If this was 0.77, they add up to 100 because that's a percent. The crash modification factor tells you how many crashes you're going to end up with after the improvement, and the crash reduction factor tells you how many crashes you're going to fix with the improvement. I mean, that's kind of like using plain English. That's what the difference is between the two. So in your benefit cost spreadsheet, you apply a cost per crash to your correctable crashes. Your correctable crashes are the ones that will be fixed by the improvement. So you would apply, if you had 100 angle crashes, you would apply to 77% of them. Those are your correctable crashes, the crash cost. Hopefully that's the question that you asked. I'm interested in systemically installing flashing yellow arrows at intersections with a left turn crash history. Who should I speak to get help with this crash analysis? We're a good place to start. If you want help with this stuff, I'm not sure if we're under contract with St. Pete to get the stuff for you, Mike, but if we are, I mean, we'll be happy to help out with one of our existing contracts. And if we're not, it's possible that the DOT may provide some assistance of some of our time to get you started with the analysis. I mean, they wouldn't allow us to do the entire study for you, but we can certainly provide some basic support to get you started with how to set up your queries and your selections. It's helpful if you have a signal inventory to do this kind of thing. I don't know if your inventory is good enough to know if you have protected, permissive, or what kind of signal facing you have. But I mean, what you'd want to do is on your system select all your signalized intersections that have left turn and angle crashes. I mean, that's your long list. You just kind of work your way down, and we QC it, look at Google Earth, do an in-office review, and figure out with the collision diagrams what direction the crashes were coming from, and figure out what you want to do, and systemically just work your way down the list. Second question for the slide and FDOT crash cost table inside the green area. Chrissy responded, we did not answer the right question. FDOT crash cost table inside the green area. Let me see if I can find that slide. Something forward from here. FDOT crash cost table inside the green area. Crash costs here.
There you go.
Inside the okay. So there are two the units for this. If you see up here, this is the legend for that particular table. The top is the cost per crashes at crashes that are regular crashes, and the bottom is the cost per crash that are injuries. For benefit cost calculations, the current methodology says that we use the crash cost, regardless of the injury severity. So you would look at only the top number, not the bottom number. The top number is the cost per crash, the bottom number is the cost per injury crash. And it's weird how sometimes it's lower and higher. That kind of gives you an idea of how many fender benders there are for that type of roadway. Like down here, because a fatal crash costs more money than a property damage only crash. I mean, if you think about property damage, it's just the insurance cost basically of fixing the bumper in your car, versus a fatal crash. I mean, there's the economic loss of there being not a person working anymore. You have all the insurance costs. You have the medical. I mean, there's an awful lot of things involved. It's millions of dollars for a fatal crash, and there's locations where the number of injuries is higher, so the injury crash cost at that location is higher. There's some like this where it's lower. That means that there's not as many injury crashes there. But yeah, I just always use the top number. And at the moment, there's no more questions in the chat. We'll kind of hang out for a second, see if anybody else types any other questions.
Well, Anthony, this is Dennis, and I just wanted to thank you and Kevin, because this is a very good presentation, very informative, and I think it probably highlighted this issue so people have a better understanding, and I really appreciate your presentation today. It was great.
Thank you, Dennis.
Thank you.
And as a reminder, here's the upcoming webinars. July 20th is the next one. Is there another slide? Yeah, download the PDH format. And again, if you're a PE and you're looking to get PDH credits, 1 hour is available for this webinar. Download the form from the handouts of this webinar and fill it out and send it to Larry Hagan. And you kind of get your certificate and hold on to that, because the way that things are now, how we have to hold on to our own data so that when we're audited, we're able to present the information to them. Well, if there's no more questions in the chat, I'll go ahead and end the recording at this time, and we'll stay on the line for another couple minutes and see if there's anything else. But thanks everyone for attending today. Hopefully this was informative. Give you an idea. I mean, the point of this is to understand the data, know what's out there, know what questions you can ask, and know that there's tools. And some of these, I mean, some of the maps and those things that are showed, there isn't necessarily a software package where you can push a button and it generates those for you. It's a combination of using Excel, using Access, using ArcMap, using GIS, using the FHIR system, using Signal 4, using the crash data management system. It's sort of, it's a whole process of getting these things squared away depending on what it is that you're working on. But know that it's possible, know that it's out there, and get your safety consultants to try to do this stuff for you. Work with your district safety engineer. There's a lot of help out there available for this stuff, and we can all be proactive and identify some projects. If your district has a highway safety improvement program process like District 7 does, you can apply for federal funds. Be proactive and identify your projects. Get them out there. The Safety Academy or the Safety Summit in District 7 is all part of that, and let's drive down fatalities through knowledge sharing. That's the point of all this. We might have had an error in our slide for the next webinar. Let me go back to Dennis's. It's going to be correct. The next webinar, I might have put the wrong date. In our slide.
Hold on.
Here's Dennis's schedule.
We do have them on the 21st September. My slide was in there. I don't think I had it.
Oh, your slide in there. I'm sorry.
Yeah.
So let's go back to. I was right. Let's go back to here. Hopefully this is right. July 15th. Yay. June 15th? July 20th?
June 15th. June 15th is road dive. July 20th is discuss the NACTO guides, and then September 21st is applying safety data analysis, and then October 19th is innovative at grade intersection design.
Okay. So when in doubt, check the Tampa Bay Traffic Safety local area traffic safety academy webpage. Follow the link in your notice, and it takes you here. And we have the upcoming webinars, and we keep this information here up to date. Sometimes we get it wrong in our presentation. Thanks, Amy, for pointing that out. Yeah. June 15th, and as always, you'll get a notice 2 weeks prior and 2 days before and day of, like you do from the system. It sends out those automatic notices. All right. Well, there doesn't seem to be any other questions. I'm going to go ahead and end the recording. Thanks everyone for attending. This was fun.